Reinforcement learning with verifiable rewards works brilliantly when a task has an outcome, check, a unit test, an exact match. But outcome-only rewards tell a model nothing about whether it reasoned correctly along the way, so researchers bolted on process reward models neural judges that score each reasoning step. The catch: a neural judge is a black box, biased and reward hackable. A 2026 paper from IBM Research asks a sharp question. What if every step is checked by a deterministic rule, not a learned judge, and that rule becomes the reward itself? The setting is risk of bias assessment for medical systematic reviews, the Cochrane kind. Every study is scored per bias domain, randomization, blinding, allocation into low or high risk. The Cochrane tool prescribes, per domain, a fixed decision tree of questions whose answers deterministically map to a risk label. That rigidity is the unlock. Each intermediate step has a gold answer obtainable by applying the rules, so the verifier is a deterministic program. No learned judge. The model emits a step identifier and a step label. The verifier checks both against the guideline gold values and composes those checks into the reward. The method: verifiable process reward models. Each reasoning step carries two outputs, a step identifier and a step label. Two bounded scoring functions map the model output against the gold, one for the identifier, one for the label. The step reward is a weighted sum. Add the terminal outcome reward, 1 if the final risk label matches gold, and you get the full verifiable process reward. Every component is a deterministic rule check. And there is a guarantee: under reward separation, correct trajectories get positive expected advantage and incorrect ones negative. Sound reasoning is rewarded in expectation. The headline: a 7 billion quen model trained with GRPO and verifiable process rewards hits 87.9 accuracy and 76.7 F1 on Cochrane Forest. That beats every pre-trained model tested, including Llama 3.1 405 billion at 68.4 and GPT-OSS 120 billion at 67.1. A 7 billion model beating a 405 billion, versus outcome-only GRPO, adding process supervision lifts accuracy by 6.4 points and F1 by 6.5. The win holds on both out-of-distribution test sets, so it is not overfitting. The cleanest single result. The paper measures coherence, the share of predictions whose risk label actually matches the decision implied by the model's own step labels. Pre-trained giants sit at 36 to 51 coherence, with coherent accuracy near 25. Even when their reasoning looks self-consistent, it rarely produces a correct judgment. The verifiable process model hits 89.5 coherence and 75 coherent accuracy. It follows the decision logic faithfully, then gets the answer right. That gap is the whole pitch: align reasoning with conclusion, don't just match the label. Here's the picture. A neural judge is a sealed black box, opaque, biased, gameable, a learned opinion layered over the reasoning it is supposed to police. The verifiable process verifier is an open decision tree. Every branch a written rule, every check auditable, no hidden weights. Swap the black box for the rule tree and you remove the reward hacking surface entirely. The reward is not a model's guess about quality, it is the guideline, executed as code. The ablation that proves the two signals are complementary. Strip the outcome reward and even full process verification collapses to 40.2 accuracy, near the pre-trained base. Outcome is essential. But add process on top of outcome and accuracy climbs from 83.1 to 87.9. Verifying that a step is correct, not just present, buys almost 5 points. Process and outcome rewards are not redundant, combining them is strictly best. 3 honest caveats. First, scope. The method needs deterministic domain rules, so it only applies to structured reasoning tasks, admitting symbolic checking. Second, single domain. It is demonstrated on risk of bias only, not legal or regulatory checklists. Third, Dabo underperforms vanilla GRPO here, and the paper does not fully explain why. One footnote worth flagging: the abstract says up to 20% higher F1 than state-of-the-art, but that magnitude matches the accuracy column, not F1, where the true gap is larger. Read the tables directly. The payoff: a 7 billion model beating 405 billion giants, 87.9 accuracy, 89.5 coherence, with a reward separation guarantee that sound reasoning is rewarded in. Verifiable process reward models replace the opaque neural step judge with a deterministic, auditable verifier composed into the RL reward. Expectation: the lever is not a bigger judge, it is a rule you can read. The paper is Verifiable Process Reward Models for Structured Reasoning. Subscribe for the next breakdown.